Our review topic for today is motion along a line. So it's talking about the relationship between the position function, the velocity function, and the acceleration function of a particle movement. We've seen this topic twice now. We saw it back in chapter 5 when we did applications of derivatives, and we also saw it back in chapter 6 or 7, I can't remember which one, when we did some applications of integrals. So I started with our relationships here. You can see the acceleration or the relationship that if you went from the direction of derivatives and then when you went from integral portion. We have net displacement, total distance, and net change in velocity as well there. One thing I made a note of here, because I think this is important to talk about, there's really no universal notation for position. So sometimes position is talked about as S of t, like I did in our relationships at the top, but it could also be talked about as X of t or Y of t if you're talking about motion along a horizontal line or an axis or a vertical axis. So please keep in mind that S, X, or Y could all be used to talk about position. So if you are going to write position shorthand, make sure you define your function somewhere as S of t is the position function and then go from there. So don't make any assumptions about that. Okay, our first example here, this one specifies no calculator, but again, you're able to use your calculator on this year's AP test. So the velocity of a function is given for a particle is given by v of t equals t sine t squared for t greater than or equal to 0. So the first question is we want to find the acceleration when t equals radical pi over 3. So acceleration is equal to the derivative of velocity. So I'm going to take the derivative of my velocity function, which I'm going to have to do with a product rule. First times cosine t squared times 2t plus the second function sine t squared times 1. And then I'm going to find v prime of radical pi over 3. So that gives me radical pi over 3 times cosine pi over 3 times 2 radical pi over 3 plus sine pi over 3, which is, this is going to be 2 pi over 3 times cosine of pi over 3. Pi over 3 is 60, so cosine of 60 is 1/2. Plus, if cosine 60 or cosine pi over 3 is 1/2, then sine pi over 3 is radical 3 over 2. And we get pi over 3 plus radical 3 over 2. Part B is asking us to find the net displacement from 0 to pi or radical pi. I think it always helps to start with notation and symbolic notation. So as we saw at the top, net displacement is a definite integral from our values, our time values, 0 to radical pi, of the velocity function, dt. So that's going to be 0 radical pi of t sine t squared dt. Now I'm going to do a u here. I'm going to say my u is t squared, which means du equals 2t dt. So 1/2 du equals t dt. When I do u's, I also like to change my bounds. So when t equals 0, u is going to be 0. And when t equals radical pi, my u value is going to be pi. So really what we're doing is 0 to pi, 1/2 out in front, sine of u du. That's going to be negative 1/2 cosine u from 0 to pi. It's the same thing as negative 1/2 on the outside cosine pi minus cosine 0, which gives me negative 1/2. Cosine pi is negative 1, cosine 0 is 1. So it looks like we're looking at positive 1 there. Letter C. Change color so it's a little bit easier to see the difference, what work goes with what. It says find the 3 smallest times when the particle is at rest. A particle is at rest when the velocity is equal to 0. So I want to know, when does t sine t squared equal 0? That's already factored. So one option is when t equals 0. The other option is when sine t squared equals 0. So we already know one value. T equals 0. Sine of t squared. Well, what I'm going to do is think about, when does sine equal 0? Sine equals 0 at 0, sine equals 0 at pi, sine equals 0 at 2 pi, 3 pi, etc. And so I would need to take the square root of all of these. So our next time value would be radical pi and radical 2 pi. I'm not going in the negative direction because if you look at the top of the question, t has to be greater than or equal to 0. So my time values where this function is at rest, or when this particle is at rest, is when the velocity is equal to 0, 0, radical pi, radical 2 pi.